Man's interference with his environment is causing critical changes in our valuable water resources. One major pollution problem is the increasing nutrient content in freshwater lakes. When first formed, lakes are usually nutrient poor or oligotrophic. The water is clear as it contains little suspended material or algae. But as time passes, natural aging occurs and some lakes become nutrient-rich or eutrophic. Lakes become choked with sediment and living and decaying plants. As layers of sediment and dead plants increase in depth, the edge community gradually encroaches out into the shallow water. Over thousands of years, lakes evolve into bogs or marshes, then into meadows and even forests. There are two main causes of lake aging. One is sediment washed into a lake from its tributaries, as well as from the lake's own banks. This erosion and deposit of sediment goes on continuously. Even this clear-looking water is carrying some sediment. The second factor is an increase in dissolved nutrients such as phosphorus, nitrogen, and carbon. These nutrients cannot be seen, but the plant life they nourish can. This increase in the amount of nutrient in a lake is called eutrophication. The green, yellow, or brown tint in water is caused by algal blooms. When these plants die, they contribute to lake aging. Nutrients are continuously recycled so that more plants grow, die, and decompose, using more and more of the oxygen in bottom waters. Consequently, species of fish with higher oxygen requirements are unable to survive. They are replaced by species with lower oxygen requirements. As the amount of dissolved oxygen continues to decrease, carp and other rough fish replace more desirable species. Slow eutrophication can be beneficial in increasing the productivity of a lake. But in many cases, eutrophication is accelerating at an alarming rate. This can be detected by measuring transparency and dissolved oxygen content. As eutrophication progresses, transparency lessens and dissolved oxygen decreases in the bottom waters. Blooms of algae cause taste, odor, water filtration, and other problems. The increased rate of eutrophication seems to be directly related to the growth of man's population around lakes. This graph shows that the population around Lake Michigan has steadily increased since 1840. There has been a corresponding increase in dissolved solids in the lake. A similar correlation exists in the other Great Lakes. The conclusion is obvious. Man substantially contributes to and speeds up the natural aging process. Domestic sewage contributes large amounts of nutrients, such as phosphorus. Detergents have been a major source. Additional phosphates come from farm wastes and fertilizers washed from fields. Eutrophic conditions caused by industrial pollution are being reported worldwide. In large cities where most land has been paved or built on, little rain soaks into the ground. Raindrops pick up dust, soot, pollen, and gases from the atmosphere. Oil, grease, animal wastes, and other debris as well are washed away. In most large cities, the same sewer that carries raw sewage from homes and offices to the sewage treatment plant is also used to carry off stormwater. When heavy rains occur, sewage treatment plants cannot handle the extra load, so raw sewage is diverted to lakes or rivers along with the rainwater. The accelerated input of nutrients speeds up eutrophication and upsets the ecological balance. Algae and other plants grow profusely. Bacteria and chemicals flushed into the water use up dissolved oxygen. Fish and other animal life die. A lake, transformed into a smelly, unsanitary mess, is often said to be biologically dead. In truth, this water is very much alive biologically. There are astronomical numbers of algae and a wide variety of decomposers. Some fish that can tolerate low oxygen levels still survive. A tragic result of accelerated aging is the loss of one of man's most valuable resources. Many communities and government agencies are turning their efforts to reducing eutrophication to slow down the aging process. Here, a lake is being dredged to remove nutrient-rich sediments which have clogged its use. The sediment and other debris are pumped onto land, where they are used as landfill. Some nutrients can be removed from a lake by cutting and removing the weeds in which they are contained. After harvesting, the weeds might be a future source of fertilizer or cattle food. This lake is being pumped out, and the highly nutritive waters are being spread out on the surrounding land. The lake will refill itself from underground springs, thus getting a fresh start. In another effort, artificial aeration is being tried to increase dissolved oxygen content. Compressors furnish the air, which is piped to several underwater outlets far out in the lake. Turbulence, caused by the escape of air, increases the dissolved oxygen content in the bottom waters. This community's lake is small, but highly prized. Here, people are contributing their time to clean out years of accumulated debris. Later, the lake will be drained so that its bottom can be covered with black plastic sheeting weighted with gravel. This will help keep the nutrients trapped below. All of these efforts should help slow eutrophication, but they are treating its symptoms, not its causes. The only long-range solution is preventing man-made pollutants from entering our lakes. Commonly used secondary treatment of sewage removes only part of the nutrients. Until treatment methods are improved, the best solution would be to divert sewage away from lakes. As early as 1900, to reduce the problem of waterborne disease, such as typhoid, from contaminating its water supply, Chicago constructed locks to reverse the flow of the Chicago River. This diverted sewage wastes from Lake Michigan and has kept lakefront waters relatively clean. Treated sewage and storm drainage now flow into a natural and artificial river system where continuous flow and mixing can better handle the incoming wastes. Seattle, Washington and surrounding towns dumped sewage into Lake Washington for many years. The nutrient-rich sewage caused a tremendous growth of slimy algae. The lake became unsafe to swim in and unpleasant for boating. Beginning in 1957, new networks of pipelines and sewage treatment plants were built to divert the wastewater away from the lake and into the offshore waters of the ocean. Lake Washington is a good example of how even a very large lake can be rehabilitated from high eutrophic conditions. But even though the treated wastewaters of Chicago, Seattle, and most other cities are piped elsewhere, they still carry high concentrations of nutrients into rivers and oceans. A third stage of sewage treatment is needed to correct this condition. In this tertiary treatment plant, solids that remain after regular secondary treatment are removed by sand filtration and microstrainers. Various means can be used to remove dissolved nutrients. Oxygen is put back in the water by bubbling air through it. The treated water, now ready for discharge from the plant, meets the standards of the Federal Water Quality Act of 1965. Sludge, a byproduct of sewage treatment plants, cannot be dumped into streams, but it can be used as a natural fertilizer. This land reclamation project demonstrates how nutrients contained in sludge can convert unused land into fertile crop-bearing farm areas. Flood control reservoirs are a way of retaining stormwaters until they can be released on a regulated basis following the storm. Deep underground tunnels, such as this one being built in Chicago, will be able to hold back millions of gallons of stormwater that would otherwise flood basements and wash untreated wastes into Lake Michigan. Much needs to be learned about how man's activities affect eutrophication. Here are sites of nuclear power plants built or proposed on Lake Michigan alone. How will the discharge of heated water, thermal pollution, from these plants affect lake aging? While all lakes are destined to age and die, natural eutrophication is a slow process, usually taking thousands of years for even the shallow small lakes. We can reduce man's contribution to eutrophication by applied research and technology, if we will expend the effort and money. What works in one lake and its surrounding area might not work elsewhere. Each lake has its own problems. Lakes are a prized resource of man, but each lake is an entity with its own ecology. Its problems must be dealt with accordingly.